Oakley dokley. What are A and B? Pardon? Zeros is one word for them. A and B are zeros. That's what our calculator calls them. They're x-intercepts. That's what you call them based on grade 10. And we also came up with another word for them this year. We call them roots. So, I can see that I have two of them. So how do I find them when I have this form? F of x equals 2x squared minus 12x. What should I do with f of x immediately?
Does f of x just mean 1?
Yes, it means the output. Did a whole unit on it in grade 10. Whole unit. Yeah, it was grade 10. It was a long time ago. I feel for you. First thing you should do is what Max just asked about. This is the output, yes? So that is y equals 2x squared minus 12x. Now what should you do? The same thing you should do every single time you see a polynomial anywhere in math class. Pardon? Factor it. What comes out of there? 2x. What stayed in there? X minus 6. If these are x-intercepts, then what is their y value? 0. So we know that either 0 has to equal 2x or 0 has to equal x minus 6. So what are the two values for x? What? 0 and 6. Lovely. He waited patiently. Excellent. 0 or 6. Perfect. That answers A. B says write down the axis of symmetry. Where does the axis of symmetry of every single parabola live? In the middle. Exactly between any 2 points, right? As long as they have the same y value. So, what is it? 3. Is that an equation of a line or is that a coordinate? That's a coordinate. Did I want a coordinate or did I want an equation of a line? Equation of a line. So what is it? X. I heard someone say X. You're a third of the way there. X equals 3. Lovely. Well done. And C. What's the vertex? What did I just write right there? What does that say? X equals 3. What does that say? 2x minus 12x. What can I do with that and that? Plug it in. So, since I want the vertex, and I know that vertex has to have an x value of 3, I just need a y value. Y equals 2 times 3 squared minus 12 times 3. What is 3 squared? Times 2. What is 12 times 3? What is 18 minus 36? Negative 18. So what is the vertex? 3, negative 18. Now, it's all written down in the paper. It's time for me to come and do a homework check, right? Because everybody's got it done because you all wrote it down now. Yeah? Awesome. Ticks for everybody. Yay! Good job, class. By all means, Cole, a round of applause for everyone. Next question. I told you how to do it. The f of the g of x. So, if this is the g of x, and I want the f of the g of x, what did I do with that x? I made it what? I made it... What did I do right there instead of writing f of x? I wrote f of the g of x. What is the g of x? X minus 2. So I must need the f of g of x, which means in my f function, what does every x get? Just like the arrow that I drew for you shows. It gets x minus 2 squared plus 3. Now, instead of writing that, what's the way I should write it to make it easy to graph? Y equals x minus 2 squared plus 3. There's A. B. What's the vertex? Vertex equals 2, 3. Excellent. Now, there's a new function, h of x. When I move the graph 5 units positively x and 2 units negatively y. So what is going to happen to my x value of my vertex? Plus 5. What is going to happen to my y value? Negative 2. So what is my new vertex going to be? The vertex of function h. 7, 1. Now, when I have the vertex, and I know there's no a, how many methods do I have to do c? Because c, I want the h of x in this form. What form do I have it in now? Vertex form. I have x minus 7 squared plus 1, yes? What form do I want it in? Standard form. So what do I do to that to find standard form? I just expand it, correct? Which is x squared minus 14x plus 49 plus 1, which is what? X squared minus 14x plus 50. Gouda? And what is D? The new y-intercept? Where do y-intercepts exist? 0y. So it is 0, 50. Yeah. All righty. Let's do some summary. Fill page 110 in with the box on 110, because I'm going to write some stuff at the bottom. but fill in the box on page 110 with your neighbor, by yourself, I don't care. Everything you can think of about standard form right there. Everything you can think of about vertex form right there. And everything you can think of factored form right there. Go! Everything I said here, and then everything I said here. Vertex form gives me x-intercepts. Vertex form is this. Does that give me x-intercepts? What does it give me? It gives me the vertex. It's called vertex form. It's a bit of a hint. Where is the vertex in here? Vertex is P, Q. But what do you have to remember? What do you have to remember about P? It's opposite sign, right? Okay. Do we know anything else from that? Yeah. The A thing still works, right? A, when it's positive, it's that. When it's negative, it's that. And it gives you your stretch. Does that work up here, do you think? Just asking, do you think that if your A down here works, that it works up here for your stretch factor? Yeah, it does. Do we know anything else from here? Okay, what can we do with it? What can we do to this? We could, yes, we can expand for standard form, which would give us the y-intercept automatically, wouldn't it? Which would get us the y-intercept. Anything else we can do with this? Cole said it already. What will it give us? It'll give you the x-intercepts if you make y what? Y has to be 0, because all x-intercepts are what, Max? X, comma, 0, yes. Excellent. And finally, if it's in factored form, which looks like this, should be plus or minus, really. What does that tell us? Gives us the roots. What are the roots? Where x plus p equals what? 0 or? Okay, what else does that tell us? Does A still work for us? Yep. A value still working. And do we know anything else from here? We know one more thing right away. We know, the roots. We know the vertex X is what? P minus Q divided by 2. Sorry, P plus Q. And what's the only thing we can get from that? Actually, we can get a couple of things from that. Can we get the y-intercept? How, Bert? Because you're right, we can get the y-intercept there. How would we get the y-intercept? What is every single y-intercept? It's at 0, y, correct? That 0 is an x, right? So where can it go? Everywhere you see an x. You can get the y-intercept from substitution. And what's the one other thing we can do? If I know the vertex X, what else can I find? Yep, you can get the axis of symmetry. You're on fire back there, Burke. X equals whatever this value is. So X equals P plus Q over 2. That's the equation of it. And there's one more thing I can get there. Starts with a V. Ends with an X. Has ERTA in the middle of it. You can get the vertex by subbing in the Vx value. Is everybody good? Did you? Well, Max, look at my hair. What color is it? My hair is not vertex form. That's not a color. Red, orange, yellow, green, blue, indigo, violet, vertex form. The V in Roy G. Biv does not stand for vertex form. Now, I said I want you to leave the bottom blank because I want to spend a quick moment reminding you of two things. Domain and range. We talked about that earlier. You talked about it in grade 10 with lines. We are going to talk about it right now with parabolas. Every parabola looks like this, yes? Or this, yes? All the parabolas we're doing. Everyone agrees, right? So, in math, what are the possible, I think I missed an S in possible. We'll wait and see. It's just like magic. Oh, I did. Posable. What are the possible domain values? Which is domain, which is range, Mr. Myers? Domain is input. Range is output. So what are the possible values for x in math? How far will this parabola go that way and that way? Pardon? Infinite. How far will the red one go that way and that way? Infinite. So what are the possible x values in math class? Negative infinity up to positive infinity. So x is a set, funny e there, of real numbers. Because every single number will work in a parabola, won't it? Because every single number can be squared, multiplied by the number, another number, and added together. Everybody agree? All right. Why did I highlight the words in math? Because in certain situations, you can't have negative values, right? Can't have negative time, right? Okay, so in reality, watch out for negatives. Okay? That's the domain. In math, how does the vertex give our range values? So I'll do the blue one first. Let's do this though. That vertex right there is 0, -5. So how does 0, -5 give us our range values? Sophie. Right. The range has to be greater than or equal to -5 on the blue one. Why? Because it's a minimum and it goes up from there. So what can we tell ourselves here? Every y-intercept is 0y, right? So if it's 0y and it's a minimum, then what's our range? The range must be greater than or equal to the vertex of the y, yes? Everyone sees that? So this one is 0, 5. So in the red one, it's 0, 5. So what's my range? Less than or equal to 5. So if it's a maximum, then my range, my y values, must be less than or equal to the vertex of the y. Is everybody cool? Yes? Do yourselves a favor and put a star or a Mrs. Bag Crumble cloud around page 110. Because that page, ladies and gentlemen, has a lot of information in one place. And based on your responses, a lot of information that was floating around in your head, but not necessarily all available in one spot in your head. Now, let's use what we know to solve this question. Where do I need to get to? Standard form. What do I know? What do I know from this graph? I know the roots are what? What are the roots? -2, 0, and 4, 0. Giving me x's and y's, yes? What else do I know from this graph? Excellent. I know the y-intercept equals -16, yes? Everyone agree? So now, what can I do? I have the roots. I know the y-intercept. What from page 110 uses more of this information? You talk to your neighbor and decide. Which section on page 110 uses the roots? Got a 1 in 3 chance. Wrote them all down. Page 110. What one of those 3 things uses the roots? Just waiting. Nothing but time. Factored form uses the roots. Nice job, Sonia. So I say to myself, self, y equals a bracket x minus p x minus q, right? Because that's factored form, yeah? So, y equals a. What's our first root? What's our first root? -2, so it's x plus 2, yes? Because it would have to be -2 plus 2 to make 0, wouldn't it? What's our other root? What was that, Megan? X minus 4, because 4 minus 4 would give me the 0 there, wouldn't it? Awesome, possums. Now, I have x's, y's, and an a. How will I find a? Can I use these x's and y's? Could I use these x's and y's? He waited patiently. If I put that x in here, what am I going to get on this side? What is -2 plus 2? What is 0 times anything else? What is 0 times a? 0. So can I use that one? No. What happens if I use that one? What's 4 minus 4? Times anything? Times anything? So these are useless to me now. They won't let me find a, will they? Will this guy? Sure he will, because this guy has a coordinate, doesn't he? What is his coordinate? 0, negative 16. Isn't that an x?
Yes.
So where can I put it? Everywhere there's an x. A. What do I write instead of x? 0. What's 0 plus 2? 2. What do I write instead of x? What's 0 minus 4? Negative 4. What do I write instead of y? Negative 16. So now I have negative 16 equals, what's negative 4 times 2? Negative 8a. How do I solve that? Divide by negative 8, and what do I get for a? 2. So now I have 2, sorry, I'm the worst kind of liar. I have y equals 2, x minus 2, x minus 4. Is that the final form I want? No, what's the final form that I want? Standard form. So what do I do there? Oh, it's x minus 2, x plus 2. Sorry, guys. So x squared, then what? Minus 2x, then what? Then what?
Minus 4 plus 4. Yellow.
It's minus 4. Then what? Minus 8. Then what? What do I do with that 2 to get the standard form? Multiply it through to get? And that's my final answer. Now, what is the point of this question? That every form uses x, y, a. If you can find any of those two, can you find the third? Or any two of those three, can you find the third? Yes. And that is where we stand now. You are going to work on 111 to 113 for homework, starting now. And that is 8, 9, 10 questions. Remember, page 110 is very helpful. Oh, Max, did you play some soccer this weekend?
Yeah, I did.
How'd it go? Nice.
Yeah.
I played some rugby. We played our most hated rivals. We did not. But get this, Max.
I'm gonna get it.
I was 10 minutes late, and when I got there, we were down by 3 tries. By the end of the first half, after I had played, we were tied. I scored a try and set up the second try. It's a very cool sport. And you know what, Max? You're never too old to play it. It does seem scary. It was very scary to me when I switched from soccer in the 8th grade. Because when I was in grade 8, I skipped a grade. So I was a year younger than everybody. So I should have been in grade 7. I was playing grade 8 rugby. And you guys are well aware. Grade 8, there's some monsters. There's some kids over at the middle school there that are grade 8s that look like they belong here. I imagine Jeffrey was quite massive in the 8th grade.
Yes.
And I was 4'6". And I went out and played rugby. I quit playing soccer and went out for rugby. But it was scary, don't get me wrong. But Max, even now, I'm still the smallest guy on the field. What? Wow, that sucks. That's crazy talk. Why would you do that? But I have extra books. Well, let's see. I'm going to have to count, make sure I have 30. But I have to write this down first. Page 111 to 113. Now, let's make sure our Akshay, if I have 3 of the Fireball Fuchsia pre-cut, or 30 of Fireball Fuchsia. I got some. What am I saying? I don't teach a class in this second semester. I'm an idiot. I've got one right here. Look at that. But I'm going to give you one of the ones that I've already worked with. Because, no, I have no beard. It's shaved now. I have no beard. See, this is skin. There is no more beard because I grew it for Halloween and then I shaved it off. Because my wife and daughter do not like it. My wife does not like, my daughter won't even let me give her a kiss, the little brat. I guess so. Don't lose another one or you're writing the rest of the year out. What? Yep. Yeah, I'll be right there. That's your stuff. What do you know? You have a vertex. So you know the vertex. Write it out. Write out vertex. With the vertex, then I'll come and talk to you. That is perfect. Okay, now, isn't that an X and a Y? Isn't that an X and a Y?
There was a vertex that's as far as
Back into it. There you go. That would be a smart move, actually. I don't doubt you, man. But I'm just trying to say, if it's been that long. Oh, is it Friday? Oh, that's not a big deal. The only reason I write is because there's so much material, right, that to keep up with the notes and to write it all down, all you're doing is talking about how to think about the notes, right? Because when I say think about it, talk to your neighbor, you're crazy trying to copy this. Which are crazy. I know that that's not a good spot for you to be in. Because I know when you've done it, you're wasting all the time to copy. So, that's right. Okay. What is that zero? What's that letter 15? What's that letter? What's that letter? So what do I put there? And then will that leave me with one unknown? And I solve any equation when there's only one unknown? Then I would try solving it if I were you.
Hey, good job. Keep it up. One day you'll make it.
I like your charcoal drawing on that page, Sophie. Your shading, your tonal drawing. I had to do a tonal drawing in 9th grade art. I drew an Ninja Turtle. I drew it really lightly with lines and then shaded and made a line so it looked like a tonal. Miss Matsioskas.
Sweet bad trouble?
No, Miss Matsioskas. Mrs. Bad Trouble doesn't exist. Miss Matsioskas was my grade 8 art teacher. I took grade 9 art for one day because a girl I really liked was in it. And then I was like, oh God, I can't do this for a whole year. And I dropped it. And I took electronics instead. Even though I still liked the girl. I liked her from grade 2, Sarah. Grade 2 to grade 10. I've told you this story. And in my grade 10 yearbook, she wrote right in my yearbook that all I would have had to do was tell her. 8 years of my life. 8 years. What? Nope. Never did. Which is why nowadays, Max, I don't mess around. That's why when I liked my current wife, who at one point was just some girl I knew, when I liked her, I made it very well known. Kinda. I waited a year. But it worked well. I only waited 1 year instead of 8. And we're still together. So I